Hello. I have a leak code test coming up, and I'm just trying to think of a project to do. I had been asked by some recruiters. Everybody wants something different. One group said, "Hey, you can learn Rust. You don't need to necessarily know it already, but we got a C++ project to port, and I guess that kind of makes sense." Um, I was doing some Python stuff just because I felt my Python was a little bit rusty. But in any case, so if we go and take a look at this, all right, I decided to go ahead and port it over to Go because Rust, there's just like way too much ceremony to do just like a stateless parser. You know, like a parser shouldn't really be your first project in Go. Um, but a lot of this happens to be a parser because Rubik's Cube is mostly group theory. It's basically like these faces by names. You know, you got stickers on them, and this would be like, let's see, up, right, front, and it has to be clockwise, and all these faces need to be clockwise. Um, you can generalize the shape. I actually use the same algorithm to solve this one, except there's, of course, there's algorithm for solving the middle and then solving the edges. Um, but what you want to do is you want to learn the theory. You don't really want to solve the cube. You want to learn the theory on how to solve the cube. And so this is front, up, right, or start from up. So up, right, front, down, left, back. And you can get confused because you get forward and back, or it could have been bottom, but they named them like this. So it's down and back because it's up, down, forward, back, right, left, right. Okay. And so this code was significantly easier once I ported what I had out of Rust back into Go, and I'm not like fighting it the whole time. So I put in some ANSI stuff a little while ago after I got the UI working. You really should have RL wrap on your machine because it makes it easy to make command line utilities and use RL wrap to simplify all the handling. Like editing things that you previously typed and whatnot. Okay, so if I were to rotate this around the upper face with Command U, that would be, so that's a rotation. So that's blue. They don't have yellow in standard ANSI, so I just use purple. They have orange, so I use purple. And then green, red. Okay. And you can turn the ANSI off and just read it by the face names. This is like standard Rubik's Cube notation, and standard Rubik's Cube notation. If you were to turn the upper face, FUR goes to RU. No, RFU. RFU. Yeah, you got to read that in the proper clockwise order. That's where the sticker goes. So the sticker like orbits around. And what'll happen is if you follow it out, you'll end up back where you were. So this is like one of the first things you learn about Rubik's Cube notation. So FUR goes to RFU, and then that means BRU goes to BUL, and it should leave me back from BUL and into FUL. In any case, that's what the notation looks like. They do the same thing for edges. If an edge orbits around, it's just two characters. It would be like FU goes to RU goes to BU goes to LU, something like that. But what I'm mostly using the notation for is to do group theory things. You can rotate the whole cube around and whatnot, but I'm just gonna like set it to colors because it makes the demo much more fun. So set it back to ANSI mode, and let's scramble it. RUFD, and just do a bunch of random moves, and as long as there's nothing illegal in there, I'll scramble it. Okay. So if I keep doing that over and over, I get a scramble. When you want to start solving something, it's best that you start with a solved cube every time, which is why you want a tool like this. If you're on a real cube, you can't just like go back and continue solving it. One of the first things that you'll notice is there's this phenomenon called a commutator. So if I take the front face and the right face and I turn them once, you see the front face and the right face are a little bit scrambled up. So you got the front, and that's the right face. And what happens is every move that you make, FR, if you do it a certain number of times, it'll have like a period. But some moves have a really short period, and something that I discovered was that if I do RU, and if you were to do /U/R, it does nothing because it brings it back to where it is. But a commutator is called a commutator, but because if you swap some things, like if I take this where it does R, does U, undoes R, it ends up doing nothing. But if I move this inside of here, I get a special object called commutator. And what's cool about this is 1, 2, 3, 4, 5, 6. It has a short period. And because it has a short period, you can use it to make ultra short moves. And so there's so many of these that there's a shortcut for it. If you put a slash, if you put it in square parenthesis, so RU would be the knot of R and then the knot of U. 2, 3, 4, 5, 6. Okay, and what's interesting is about that is that means that if you were to do this 6 times, R, U, okay. So if I do that 4 times, then I need to do 2 more to solve it. Okay. What? So let me look again. RU. Oh yeah, 1, 2, 3, 4, 5, and then I do a 6th one. Right, and it looks like I did nothing to it. It's still solved. So what you do is you discover that there's interesting things that you can do with this. If the period of 2 faces, you just turn forward and then turn back, where you like interlock them and swap them. Right. So that means if I were to take something like a U and an inverse U, it should do nothing. But that means that if I put it in the middle of this, then it should do something that's like really, really short. So there's U and there's inverse U. Okay, so interesting. 1, 2, 3. Not only does it have period 3, it literally only swaps 3 pieces to do that. That's pretty cool. So that is one that I made up. I saw a Mathologer video and I kind of knew the theory already, but yeah, but just like 3 periods. So you can basically make your last layer move out of this. It's basically this done 6 times. Where what you do is you say FR. You do this 3 times, and then you do a U, and then you do FR 3 more times. 2, 3, and then you do an inverse U. Let me start over. That's exactly why we do it this way. 1, 2, 3, right? And there's very little change. So type U, and then I do this 3 more times. That's because the period on it is 6. And yeah, so I've only got 3 colors swapped. And then I learned through that methodology video, like how to make your own moves, I learned that I can do something similar, where if I do the front and down, and if I do that 6 times, because it's 2 adjacent faces, okay, 1, 2, 3, 4, 5, 6. So if I do that, am I missing one? Front down, front down, front down. So I want 2 of those, and I want, oh, I added an extra one. That's what happened. Yeah, and then front down, front down, front down, front down. Why is that? Hold on a second. Let me clear it up. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So what this means, if I do this 1, 2 times, since the total repeat is 6, here it happens to be that if I turn the face at 2, then I get 4. All right, 1, 2, 3, 4. And if I do 4 of them, then what happens is I have only swapped a single corner in the white face. Well, I've twisted it actually. So what happens if you're done moving all the cubies and the physical cubes into the right spots, but they're twisted the wrong way? This is what you use to twist it. So using those moves, I was able to create my own final layer solve. The thing is you can do solves on a computer. On the keyboard, it's like really really hard actually. I did finally do it, but I didn't put anything to help you out with anything other than resetting. I was spending all my time trying to get the language right. The real commutators are correct, but like these pseudo commutators that would like have a different period than the faces have. Like faces have a period of 4. Like if you do like right, 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 is back to clear. If you do front, 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 right? So you see if I turn the red face clockwise, you'll see that the white strip went to the right, and then the right strip went down, and then yellow, the yellow went to where green is, and so it's like orbiting, and that's they call those orbits. Okay, so the idea is you use this to just like get your mind bent around how to actually make commutators correctly. Yeah, and the main thing, like for instance, if I want to, if I get like the first 2 layers solved, that it's usually easy to get like the first the cross on top of white, and place the corners. You don't really need algorithms for that, but it becomes kind of hard when you need to like put in the first edge pieces into where the corners are. And the way that you figure that out is you discover that there is a move called let's see, right. If I'm on here, so I do right, down, right, down, yeah. So I just want to do it mentally because I don't want to mess up the cube, because I have to solve the whole thing. So right, down, negative, right, down. Notice that's not quite a commutator because the D went in the wrong direction for being a commutator, but it's kind of close to one, so we'll be able to fix that up. So if we do right, down, and then we do front, negative, down, and then that's a commutator. So front, negative, down, and then that means negative front, down. And if I did this right, no, I didn't do it right. Right, down, yeah, yeah, actual right. right, down, right. Yeah, negative right, down, right, and then another down, and then front, down, negative front, down. Okay. Yeah, that's start from the beginning. Yeah, that's what I'm looking for. So what we have is the white face is solved on the top. But when you're looking at the red face, what would happen is if this piece is not in the right spot, what you do is you put it here where the red sticker is at this spot, and I want it to be in that spot. And you'll notice that the red blue edge moved to that spot that I'm pointing to, right? So this thing ended up over here. So you can tell that they're related. All right, so that's the idea. Is yeah, so that's now solved. So if I'm in this position where I put it there, then you basically what you do is you do that move backwards, and then you're in the right spot. And I'm not sure if I got this portion of it correct, but I should be able to just negate it and go back. Yeah, and then I'm back. So I either go forward and then I go back. And yeah, and now that piece is in the right place. Okay. And yeah, ASCII new cube. But in any case, this was something I didn't think would take all that long because I have written Rubik cube before. It was actually the language. Some things are right. The commutators work properly if there are only like primitives inside of it, you know, like R and like say, well, give me an idea of what I mean by commutator. Since this is like a multiplicative type of notation, R divided by R should do nothing, right? It's literally, it like does like what we call 1. And then if I were to say RF divided by RF, I also get nothing. I think the commutator, I'm not sure if that's going to work like that because it's not doing negate in the order that I was expecting. But let me attempt this. Yeah, it's not really doing it right. So what I would have to do is I would have to actually spell out the commutator. So if I do RF divided by FR, I reverse it manually. Yeah, that has a period 6. So that's actually another way of expressing the commutator. It's kind of like division, except you swap the order before you do the divide. So 1, 2, 3, 4, 5, 6, right? And then yeah, so if I do that 3 times, RF, FR, RF, one, two, 1, 2. So it has period 2, right? Because there are 6 required. Oops, you gotta divide by FR. All right, so I did that right, so that does nothing. And then if I put a U and a /U, it should also do nothing. But if I switch the order and I place it in between, you know, after the third one, then I should have a move that just does something really, really tiny. Because that's like when it goes through its orbits, like the smallest thing is like somewhere in the middle. Like if it's 3 times 2, it does something at 3 and it does something at 2, right? And 6 is 3 times 2. And because 6 is 3 times 2, I can put that there, or I can use left and not left. And if I start from, yeah, so it does nothing if I start from nothing. Left and not left happens to do something interesting at period 2. Right, so that twist a corner. So that's literally like how you make your own algorithms. And if you're on a physical cube, you have a problem that you can't just solve a button, and you can't just like press a button and resolve it. Anyways, you have to learn the notation. So that's how you learn the notation. It wasn't Rust code, but Rust is just like super verbose with like unwraps and clones, and it's kind of ridiculous. I can't believe some of the things you can't like just do in Rust. Some of the restrictions don't make any sense. But anyways, I just went back to Go for that. I will have to learn Go. I will have to learn Rust for at least one of the people that I'm talking to, but everybody's like a 1% thing. Anyways, I will get back to learning Rust when I have to, but I wanted to like finish this project up because I'm about to take my leak code test, and I wanted to finish up my little project before I take it. I waited a week to take my test for Capital One. I almost never pass leak code tests. I hope I do, but they're so easy to fail on time. But anyways, that's it.